This is an audio recording for Lesson 1, Representing Data. The essential question we will be exploring in this lesson is how do scientists show the results of investigations? By the end of this lesson, you should be able to use tables, graphs, and models to display and analyze scientific data. Engage your brain. Number 1, evaluate. Check T or F to show whether you think each statement is true or false. A graph should always have a title describing what the graph is about, true or false. The factor that is manipulated in an experiment is usually plotted on the vertical axis of a graph, true or false. A model can be used to represent something that is too small to see with the naked eye, true or false. Number 2, assemble. Write a word or phrase beginning with each letter of the word model that is an example or use of a model. Think of a model as anything that represents something else. Active reading. Number 3, apply. Use context clues to write your own definition for the words independent and dependent. Example sentence. After independent studies, the two scientists reached two very different conclusions. Independent. Example sentence. The cost of the service is dependent on its availability. Dependent. Although the vocabulary terms section is not graded, I encourage you to do this independently. The vocabulary term says independent variables, dependent variables, model. Number 4, apply. As you learn the definition of each vocabulary term in this lesson, create your own definition or sketch to help you remember the meaning of the term. Modeling data with graphs. How do scientists make sense of data? There are many different kinds of scientific investigations conducted in science, all of which involve the collection of data. Data are the facts, figures, and other evidence scientists gather when they conduct an investigation. Scientists organize the data. Scientists use tables to organize and record the data they collect. By creating a data table, they can record their observations and measurements in an orderly way. Data tables often have 2 columns. One column lists the independent variable. This is the variable that is deliberately manipulated in an investigation. The other column lists the dependent variable. This is the variable that changes as a result of the manipulation of the independent variable. When creating a data table, any unit of measurement, such as seconds or degrees, should be included in the table's column heading and not in the individual cells. The title of this table is Drink Cells. The left column title is High Temperatures Degrees Fahrenheit. The right heading is Numbers of Cold Drinks Sold. When it is a high of 25 degrees Fahrenheit, 43 drinks were sold. When it is a high of 40 degrees Fahrenheit, 55 drinks were sold. When it was a high of 58 degrees Fahrenheit, 60 drinks were sold. When it was a high of 70 degrees Fahrenheit, 72 drinks were sold. When it was a high of 81 degrees Fahrenheit, 70 drinks were sold. Visualize it. Number 5, apply. Name the independent variable and the dependent variable in the data table. Explain your answer. Please take the time now to pause this audio recording to record your answer. Scientists graph and analyze the data. Scientists often analyze data for patterns or trends by constructing graphs of the data. The types of graph they construct depend upon the data they collect and what they want to show. A scattered plot is a graph with points plotted to show a possible relationship between two sets of data. A scatter plot has a horizontal x-axis and a vertical y-axis. The x-axis usually represents the independent variable in the data table. The y usually represents the dependent variable. To show the general relationship between the two variables in the graph, a line of best fit is often used. A line of best fit is a line that is drawn to fit or come close to most of the data points. The graphs below show steps used to construct the scattered plot of the drink sales data at the left. Active reading. Number 6. Identify. Which axis of a graph usually represents the independent variable? Please pause this audio recording to record your answers now. Step 1. Label the axis. Label each axis on a graph with the name of the variable that is represented. Each axis can have its own range and scale so that the data can be seen easily. The range is the difference between the greatest value and the least value of the variable. The scale is the size that is used for each box or grid marked on the graph. Step 2. Plot the data points. Plot the data from the table as the data points on the graph. Number 7. Analyze. Do you see a trend in these data? Explain. Please pause the audio to record your answer now. Step 3. Draw a line of best fit. Draw a line that comes close to most of the data points. The line shows the pattern described by the data. It also shows how the data differ from the pattern. What do graphs show? Different types of graphs are used to show different types of information about data. On the previous pages, you read about scatter plots. Other graphs include bar graphs and circle graphs. A bar graph is used to display and compare data in a number of separate or distinct categories. Data about the number of inches it rained each month can be displayed in a bar graph. A circle graph is used when you are showing how each group of data relates to all of the data. Data about the number of boys and girls in your class can be displayed on a circle graph. Active reading. Number 8. Name 3 different types of graphs. Please pause the audio now to record your response. Visualize it. Dwayne has been training for several weeks for cross-country tryouts. To make the team, he must be able to run 1 mile in less than 8 minutes. The data at the right shows the amount of time in minutes it took Dwayne to run a mile each week. Number 9, compare. Use the empty table below to organize Dwayne's running data. Include a title for the table, the column heads, and all of the data. On the right, it says for week 1, it took him 11.95 minutes. On week 2, it took him 11.25 minutes. On week 3, it took him 11.4 minutes. On week 4, it took him 10.10 minutes. On week 5, it took him 9.25 minutes. On week 6, it took him 8.6 minutes. Please pause the audio now to fill in the table. Visualize it. Use the steps below to construct the graph of Dwayne's running data. The horizontal and vertical axes have been drawn for you. Step 1. Label each axis with the name of the variable that is represented. Step 2. Find the range of each axis. For the running data, the range of the independent variable is 6 weeks. Thus, the x-axis must cover at least 6 weeks. Step 3. Decide the scale of each axis. For the running data, Use a scale of 1 week for each grid mark on the x-axis. Step 4. Graph the points by putting a dot on the graph for each pair of data in the data table. Step 5. Title the graph. A good title tells the reader what the graph is all about. Number 10. Graph. Use the steps at the left to construct a scatter plot of the running data given. Please pause the audio now to record your response. Number 11. Assess. Explain how you could use the graph to predict whether Dwayne will run 1 mile in less than 8 minutes. Please pause the audio now to record your response. Remember, use full and complete sentences. Throw me a curve. What kind of patterns can be shown using graphs? When you graph data, you can identify what patterns or trend a data is. A trend shows the relationship between the two variables studied in the experiment. Graphs make it easy to tell if something is increasing, decreasing, or staying the same. Linear relationships. A line can sometimes be used to show the trend of data on a graph. A graph in which the relationship between the independent variable and the dependent variable can be shown with a straight line is called a linear graph. A straight line shows that the rate of change of the dependent variable with respect to the independent variable is constant. In other words, y always increase or decrease by the same value in relationship to x. Visualize it. Number 12, interpret. Use the graph to determine the mass of 7 centimeters cubed of water. Please pause the audio now to record your answer. And remember, the density of water is an example of a linear relationship. Non-linear relationships. Sometimes the graph of the relationship between the independent variable and the dependent variable studied is not a straight line but a smooth curve. Any graph in which the relationship between the variables cannot be shown in a straight line is called a non-linear graph. Graphs allow scientists to determine the relationship between variables. In a direct relationship, the value of one variable increases as the value of the other variable increases. In contrast, an inverse relationship is one in which the value of one variable decreases as the other one increases. The graph of a direct relationship is upward sloping line. The graph of an inverse relationship is a downward sloping line. Active reading. Number 3, apply. Describe the difference between linear and nonlinear relationships on a graph. Please pause this audio to record your response. Both of these graphs show a nonlinear relationship. Visualize it. Number 14, infer. Describe the relationship shown in the graph of Susie's surf shop sales. Then use the graph to find the approximate sale of the surf shop in 2007. Please pause the audio now to record your response. Active reading. Number 15, apply. As you read, underline some examples of models. How do scientists select a model? A model is a representation of an object or a process that allows scientists to study something in greater detail. The best models are those that most closely resembles the system, process, or object they represent by the kind of information it shows. Scientists use many different kinds of physical and mathematical models. A physical model is something that is drawn or built. Maps and globes are some of the oldest types of physical models. These are two-dimensional models, if it's flat, of course. Two-dimensional models have length and width, but not height. A three-dimensional model has length, width, and height. A diorama of a classroom is a three-dimensional model. Scientists also use mathematical models to represent how the natural world functions. With mathematical models, you can predict the results of change in a system. A computer simulation is one type of mathematical model. Visualize it. Number 16, defend. Identify an advantage of this precipitation map over tables of the same data by how it can be used. A two-dimensional floor plan of a building would give you a good idea of the building's layout. You can add furniture to the floor plan to see how you could use the space, but you would not be able to determine anything about the height of the furniture in the room. A three-dimensional model would allow you to see the walls and windows and get a better feeling of how objects fit in the room. A computerized simulation of the building could enable you to see what it would be like to move through the building. Similar models could be made of a molecule such as DNA. A two-dimensional drawing of the molecule would show the atoms that make up the model and how those atoms are arranged. A three-dimensional model would enable you to study the molecule from different angles. A simulation would enable you to see how the molecule functions. Today, many processes in science can be modeled in great detail. The information needed from the model determines the type of model that is used. Think outside the book. Inquiry. Number 19, criticize. Many advertisements feature models. Find an example of a non-human model in a magazine. Write a critique of the model. Consider the following questions. How useful is the model? What has been left out or exaggerated? How could the model be improved? Please take this time to record your response and pause the audio. Number 18, predict. Scale is the relationship between the dimensions of a model and the dimensions of the real object. How could the scale of this map be helpful when taking a trip? Please pause the audio to record your response. Inquiry. Number 17, infer. What are two advantages of the globe over the precipitation map of Florida for understanding the characteristics of Florida? What are two advantages of the map over the globe? Please pause the audio to record your answers. Visual summary. To complete this summary, circle the correct word, then use the key below to check your answers. You can use this page to review the main concepts of this lesson. A graph in which the relationship between an independent and dependent variable can be shown with a straight line in a linear graph. Number 20, the dependent or independent variable is usually found on the x-axis of a graph. Please pause this audio to record your answers now. A graph in which the relationship between the variable cannot be shown on a straight line is called a nonlinear graph. Number 20. If the rate of change of the dependent variable with respect to the independent variable is not constant, then the relationship between the variable is linear or non-linear. A scientific model is a representation of an object or a system. Number 20. A globe is an example of a mathematical or physical model. Please pause the audio to record your answers now. Number 23. An equation is an example of a mathematical model or physical model. Please pause the audio to record your answers now. Scientists select models based on their advantages and limitations. Number 24. A roadmap is a two-dimensional/3D model. Please pause the audio to record your answers now. Number 25. Conclude. You and a friend each decide to build the same model airplane. After the airplanes are built, you decide to conduct an investigation to determine which airplane can glide through the air the longest. Outline a plan to conduct your investigation. Please pause the audio to record your response now, and remember, use full and complete sentences. At this age, we are no longer learning how to read, but we are reading to learn. And so at this point of the lesson, we are trying to determine if we actually understand and learn from what we read. Lesson review. Vocabulary. Fill in the blank with the term that best completes the following sentences. Number 1, the blank variable in an investigation is the variable that is deliberately manipulated. Number 2, the blank variable in an investigation is the variable that changes in response to change in the investigation. Number 3, blank can be a physical or mathematical representation of an object or a process. Key concepts. Number 4, identify. Alfonso is conducting an experiment to determine whether temperature affects how fast earthworms move. What are the independent and dependent variables in his experiment? Number 5, apply. When creating a graph, why is an appropriate title for a graph important? Number 6, provide. Give an example of a model used in science that is larger than the real object and an example of a model that is smaller than the real object. Critical thinking. Use this graph to answer the following questions. Number 7, interpret. In this graph, what are the independent and dependent variables? Number 8, describe. Explain a trend or pattern you observe in this graph. Number 9, analyze. Both a globe and a flat world map can model features of Earth. Give an example of when you would use each of these models. You've now reached the end of the lesson. Please remember to press submit to have your responses recorded on a Google form.